I'm going to talk about the complementary angle identities. Okay? So let me start by drawing a right triangle and labeling the lengths of all these sides and the measures of all the angles. So I'll refer to the length of the hypotenuse as C, the length of the vertical leg as B, the length of the horizontal leg as A. I'll refer to one of the acute angle measures as theta. And in degrees, we know that that would imply that the other acute angle measure has to be 90 degrees minus theta. Okay? Now, in radians, it would be pi over 2 minus theta. Okay? Now, if you work out the sine, cosine, and tangent values for the two given acute angles, you will notice something interesting. You will notice that the sine of 90 degrees minus theta is equal to the cosine of theta. Okay, for the example triangle that I drew there, both of those function values are equal to a over c. All right. You will also notice that the cosine of 90 degrees minus theta is equal to the sine of theta. Both of those are equal to b over c. Okay? And furthermore, you will notice that the tangent of 90 degrees minus theta is equal to the reciprocal of the tangent of theta. Okay? Both of those expressions are equal to a over b. All right? Now, the three identities, we've established three identities. Okay, these identities are known as the complementary angle identities. All right. Now, for the sake of completeness, let me write the same identities in radians. So the sine of pi over 2 minus theta is equal to the cosine of theta. The cosine of pi over 2 minus theta is equal to the sine of theta. And the tangent of pi over 2 minus theta is equal to the reciprocal of the tangent of theta. All right, let's confirm this for a example triangle. All right, suppose we had a what's called a 30, 60, 90 triangle with a hypotenuse of length 1. So that would imply that the horizontal leg length is 1/2 and the vertical leg length is √3 over 2. So go ahead and work out, if you like, to convince yourself what the cosine of 30 is, and you'll see it's equal to the sine of 60. And you'll further see that both of those values are the square root of 3 over 2 on your calculator. Okay? Also, work out the sine of 30 degrees and the cosine of 60 degrees. You will see that they're both equal to 1/2. Okay? Also, with your calculator, work out the tangent of 30 degrees, and you'll see that it's equal to 1 over √3, or √3 over 3. And you'll see that the tangent of 60 degrees is equal to the square root of 3. So the tangent of 30 degrees and the tangent of 60 degrees are reciprocals of each other. Okay? You'll find these identities very useful. All right? Now, let's finish by having you try one more exercise. Okay? So, I want you to calculate some trig values without a calculator, and I'm going to give you some hints. The cosine of 56 degrees is equal to 0.56. The sine of 56 degrees is equal to 0.83. Using those two given values, would you please tell me, without using a calculator, what is the sine of 34 degrees, what is the cosine of 34 degrees, and what is the tangent of 34 degrees? All right? Pause the video and try to do those now. Okay, I'll go ahead and work these out. So, an angle with a measure of 56 degrees and an angle with a measure of 34 degrees are complementary angles. Therefore, the sine of 34 degrees is equal to the cosine of 56 degrees. The cosine of 34 degrees is equal to the sine of 56 degrees. And we can work out the tangent of 56 degrees by taking the ratio of the sine and cosine of 56 degrees, and that'll give us 0.83 over 0.56, or 83 over 56. So now we take the reciprocal of that, and that gives us that the tangent of 34 degrees is 56 over 83. And I hope that those are the three answers that you got.